Okay, this lesson is to show you how to divide any type of polynomial by a monomial. Okay, if we remember, a polynomial is a type of algebraic expression. This covers AA14, which is divide a polynomial by a monomial or a binomial. In its particular case, that the quotient has no remainder. Okay, you'll learn in Algebra 2 how to divide a polynomial by a monomial when there is a remainder. But in Algebra 1, you just learn about when the quotient doesn't have a remainder. Okay, so the types of the vocabulary that we're going to go over is polynomial, monomial, binomial, and actually trinomial is another thing that we're going to cover. Okay. Okay, so there are several different cases. This standard covers several different cases. So case number 1 is a monomial. I'm just going to abbreviate it, divided by a monomial. Okay, and that would look like something like 8x squared y divided by 4y. Okay, that's case number 1. Case number 2 is a binomial divided by a monomial. Okay, so that would be something like 16xy plus 8x squared y divided by 4y. Okay, so at the top there is a binomial and the bottom is a monomial. Right, and I'll show you, I picked those ones in particular because there's what you get when you divide this binomial by this monomial is another binomial. Okay, in case 3 is a trinomial divided by a monomial. Okay, so that's something like 24xy squared plus 16xy plus 8x squared y divided by, let's say, 4y. Right? So in this case, we're going to get a trinomial as a result. The quotient of these two polynomials is itself a trinomial. Okay, and you could say that there's multiple other cases where you would just have like maybe a 4-term polynomial divided by a monomial. So after we go over case 1, 2, and 3, you'll be able to generalize and see the algorithm for dividing a 4 or 5 or 6-term polynomial by a monomial. Okay, so let's cover case number 1, which is a monomial divided by a monomial. All right. So the first thing we do is we look at the coefficients, and we divide the coefficients first. Okay, so let's do that right here. So the object on top is a monomial because it's just everything's attached with multiplication. You see no addition or subtraction. Addition and subtraction are the operations that separate terms in a polynomial. So like 3x plus 4 would be a binomial because you have addition separating the two terms here. Okay, so the numerator in example 1 is a monomial and the denominator in example 1 is a monomial. So let's just think about the coefficients here. We have 21 divided by -7. Okay, and then let's separate the other the coefficients part from the parts of the terms with the powers of the variables. So let's write the second parts in their own little fraction here for a minute. So we have x squared y to the 4th over xy. Okay, so the first thing I do, and I'm just writing, you're eventually not going to have to write all this work down, but in our first way of looking at it, the first time you look at it, I want you to think of it in your mind as having sort of two separate parts of your problem. You have the part where you divide your coefficients and the part where you divide your variable powers. Okay, so 21 divided by -7 is -3. All right, so we just divide those regularly. Now, we talked about dividing powers before, where when we have x squared divided by x to the first power gets you x, because we keep the base of x and we subtract the exponents. Well, 2 minus 1 is 1, and x to the first power is x. So x squared divided by x is x. So we're going to write that in here. Okay. And then finally, we have this other part of the term, which is y to the fourth divided by y. Well, again, this is the quotient of powers rule. We keep the base, and 4 minus 1 is 3. So the last part of our monomial is y to the third. Okay, so the answer to all of this problem is 21x squared y to the fourth divided by negative 7xy is negative 3xy to the third. Okay, so in our minds we're going to want to think of dividing the coefficients, and then we divide each power with the same base as we go through the monomial. Okay, so for this one, on the top the coefficient is 10, but remember, whenever you see a negative sign like that, you want to think of that as a negative 1 as a coefficient. So the bottom can be rewritten this way. Okay, so this is 10x squared y to the 10th over negative 1 y to the 10th. Okay, so we're just going to do this with a little bit less work now. So 10 divided by negative 1 is negative 10. Okay, and let's see, x squared divided by, oh, we don't have an x in the bottom, so actually the x squared just remains there. Okay, and y to the 10th divided by y to the 10th, there's a few different ways of looking at that. You can say, well, y to the 10th divided by y to the 10th, well, that's just one thing divided by itself, that's 1, as long as y is not equal to 0, and I should have put that qualifier on there because you can't divide 0 by itself. 0 divided by 0 is undefined. Okay, but you can also think of that as the quotient of powers rule. So you'd keep the base of y, and you'd subtract 10 from 10, and you get y to the 0 power. Well, as long as y is not equal to 0, y to the 0 power is 1. Okay, so all in all, you'd have this monomial as a result. Okay, but 1 times anything is just itself, so really the answer is negative 10x squared. Okay, so let's erase everything that we have here, just so you can see the final result. This right here results in negative 10x squared, because if you looked at these two, 10 divided by, if you look at essentially 10 and the negative symbol, which is 10 divided by negative 1, you'd have negative 10. X squared remains because there's nothing to be divide it by, and y to the 10th divided by y to the 10th is 1. Okay, so that covers case number 1. Now case number 2 is taking a binomial and dividing it by monomial. Now in this case you really want to be a little bit more careful, because here on the top we have a binomial. We know that because addition is separating the two terms there. And what you want to think of this as is you want to think of the binomial, it has two terms, so really you are doing two quotients. Okay, not just one quotient like we did with a monomial divided by a monomial. So the first thing we want to do is we want to split the numerator up by term and divide each term by the monomial in the denominator. So really I want to think of this as 18x squared divided by 2x. And I want to carry that operation over here. It's a plus sign. Plus, and then I want to take the second term and divide it by the monomial. Because that's what it's saying. Okay? And if you think about the connection to long division with numbers, that's what we're really doing with numbers as well. Like if I had 4 and I wanted to ask how many times it went into 256, the first thing I do is I say, well, how many times does 4 go into 2? Well, it doesn't, so I put a 0 there. How many times does 4 go into 25? So what you're doing is you're going and asking, you know, if it's 256 divided by 4, you're asking how many times 4 goes into each of the places there. The hundreds place, then the tens, then you think of this as 25, and then you think of that as 6. So really, that is what you were doing when you were doing long division too. The way that you, the algorithm for it is asking how many times it goes into each of those parts of that number there. And that's what we're doing here too. If we look back at what we had a binomial divided by a monomial. So we're asking how many times, first of all, how many times does that monomial go into that part of the binomial? And then how many times does the monomial go into that part of the binomial? So you split it up into two different quotients here. Okay, and then you use your rules for dividing a monomial by a monomial that we just covered. Okay, 18 divided by 2. So we have 18 divided by 2 is 9. X squared divided by x to the first power is x. We carry that addition down. 20 divided by 2 is 10, so that's the new coefficient. And x to the fourth divided by x to the first is x to the third. Now remember, a very common mistake that I see all the time is when a student is doing this, and they think of this, for some reason, because they don't see the exponent, the implied 1 on this x term, they think of this as, they say, it's x divided by, okay, well I don't see an exponent here. So they'll say, I don't see an exponent here. Keep trying to erase this exponent. They'll say, x to the fourth divided by, there's no exponent, so that's x to the fourth. It's a very common misconception, but remember there's an implied 1 there. So you're actually supposed to be subtracting 1 from 4 and you get x cubed. Okay? So back to our problem, we have, we've just divided this binomial divided by a monomial, and we get this as a result. And notice there's nothing else I can do here because 9x and 10x cubed are not like terms, so I don't add them together. So that's my answer right there. Okay, 18x squared plus 20x to the fourth divided by 2x is 9x plus 10x to the third. And you know what, you actually, you might want to end depending on, I like to write it in descending terms, so you actually might want to end by writing your polynomial, in this case your binomial, in descending terms. Okay, example 2 covers our third case, which is a trinomial divided by a monomial. So we're going to continue with the algorithm we established in the previous example, where this is 3 terms, 1, 2, 3, and we are going to divide we're going to split it up into 3 quotients. So we have 15x squared y divided by negative 1xy. We're going to carry the operation down between the monomial parts and rewrite this. And then we have that operation there. And we have x squared y squared over negative 1xy. Okay, so we've just made 3 separate quotients. Okay, because essentially what you're doing is you're looking at what this monomial is divided by that, and then you're subtracting it from what this is divided by that, and then you're adding that to whatever this last term is divided by the monomial. So you have 3 different quotients there. Okay, so when we do this out, 15 divided by negative 1 is negative 15. X squared divided by x to the first power is x. And y divided by y is just 1, so you don't need to write that down. Keep the subtraction sign down. 5 divided by negative 1 is negative 5. Okay, notice that subtraction comes from the operation above, and this is not a subtraction symbol, it's a negative sign, because 5 divided by negative 1 gets you negative 5. Okay, x divided by x, those x's just cancel to get 1, so we don't have to write it there because we don't write 1 in a product. And then y squared divided by y to the first power is just y. And then we carry down that plus symbol. Now, there doesn't appear to be a coefficient on the final term of that trinomial, but remember, you want to consider the coefficient when you don't see it to be 1. So 1 divided by negative 1 is negative 1. So I'm going to write negative 1 as the coefficient here. X squared divided by x to the first power is x to the first power. And y squared divided by y to the first power is y to the first power. Okay, all right, let's clean this up a little bit here. So we have, let's keep this as negative 15x this right here, this combination of subtracting a negative, is a plus. And this combination of adding a -1, we can just think of as subtracting. And we do not have to put that 1 there because 1 times xy is just xy. Okay? And you'll notice that there are no like terms here. This term has an x, this term has a y, and this term has an xy. So that is as far as you can go with this problem. And if you want to write it in terms of descending powers, well, this is sort of the way. This is the way that you would do it. Except if some people would like to write the combined xy term in the middle. So it doesn't matter to me at this stage because these are all the powers that we see here are to the first power, so we don't have to really write it. It is in descending power. It is just in descending order. Okay, and then our third example, we have a binomial divided by a monomial, but I made it a little trickier by making the coefficients decimals. Okay, so first of all, let's just rewrite this the way that we were showing before, separating the terms in the numerator and dividing them each by the term in the denominator. Okay, so hopefully I just copied that right. Now I want you to remember, so I'm going to do a little side work over here. I want you to remember that 0.1 is 1/10. Okay? And 0.001 is, let's see, that's 1 in the tenths, hundredths, thousandths place. So that's 1 over 1,000. Okay? So the coefficients right here in the first monomial, that's just saying 1/10 divided by 1,000th. Okay, so really that's asking how many 1/1000th parts are there in 1/10. And remember, when you divide a fraction by a fraction, you keep, change, flip. So you keep the numerator, you change the division into multiplication, and you reciprocate the denominator. Okay, well, then we multiply across. 1 times 1,000 is 1,000. 10 times 1 is 10. So now we just have 1,000 divided by 10. So let's just sort of cancel the powers of 10 we have here. This 1,000 is 3 powers of 10, and 10 is 1 power of 10. We can cancel powers of 10 by canceling out their zeros. So now we have 100 divided by 1. Well, that's just 100. So in essence, there are 100 1,000 parts in 1/10. Okay, so the coefficient right here becomes 100 by the work we just showed below, and then a squared divided by a to the first power is a, and b squared divided by b to the first power is b. Okay, now let's erase our work right here so we have a nice workspace to divide the other coefficients. Okay, so this was, and again, this right here, 0.01 is 1/100th. So it's saying 100th divided by 1,000th. And again, we keep the numerator. We change the division, which is represented with a fraction bar, to multiplication. And we reciprocate the denominator. Okay, well, then we multiply across. That's 1,000 divided by 100. And again, I'm going to cancel the powers of 10 by using my shortcut of canceling out the zeros. So now we just have 10 divided by 1, which is 10. Okay, so the coefficient here is 10. Okay, so I'm going to write it down below here. So I have plus. Now that is 10. Actually, let me just rewrite it under the space below here. Okay, we have 100 a, b, plus, that's from this monomial, plus now this monomial, the second monomial division, results in 10 as a coefficient, and then the a's cancel, so you just have 1, which you do not need to write, and b squared divided by b to the first power is just b. Okay, notice again you have no like terms because that term has an ab, and that term has a b, so you can't add anything together, so this is your final answer. Okay, sometimes in algebra it's difficult to know when to stop because you think that you should just have one answer, or you should think that your answer should be just a number. And oftentimes it's an expression, or in this case, the expression is a polynomial, and in particular, it's a binomial. But there's nothing else we can do with it because there's no like term. So that's how we know we should stop. Okay, so you can go ahead and do the practice for this section.